All of our previous derivative rules and properties carry forward now that we're looking at finding second derivatives. So for instance, in example 3, we're going to be applying the power rule since we have a power function. All that's really changing with finding the first and second derivative is paying attention to what function you're differentiating at each step. In part A, we're finding d over dx of p of x, meaning we want to find the derivative of the original function, 2/3 x cubed. 2/3 is just that constant multiple, that coefficient. So this will be 2/3 times the derivative of x cubed, which will give us 3x squared. And then simplifying a little bit, 3 over 3 will cancel. Our final result will be 2x squared. Then in part B, to find the second derivative, d squared over dx squared of p of x, we'll take the derivative of the first function. We'll take the first derivative of the function, 2x squared, and then differentiate. We're differentiating another power function, so we'll apply that same property. This will become 2 times the derivative of x squared, which will be 2x to the first power. Then simplifying a little bit here, we'll end up with 4x as the result for that second derivative. If we have a function with multiple terms, we can still use the sum and difference formula for derivatives and differentiate term by term, meaning to find r prime of x, we'll differentiate 5x to the negative first power minus the derivative of 2x to the negative sixth power plus the derivative of x. And again, differentiating term by term, we would end up with negative 5x to the negative second minus 2 times negative 6x to the negative seventh plus 1, or negative 5x to the negative second plus 12x to the negative seventh plus 1. Then to find r double prime, the second derivative of r of x, we'll differentiate the first derivative term by term. And that will give us negative 5 times negative 2 will be positive 10x to the negative third. Negative 7 times 12 will give us minus 84x to the negative eighth. And then we don't need to write it out, but just to put in a placeholder to show us the derivative of 1 goes to 0.